Hello everyone, this is going to be the introduction for lab number 3, the basic op-amp circuits. And in this lab you are going to build a couple of op-amp circuits including inverting amp, non-inverting amp, voltage follower, which is kind of subset of this non-inverting amplifier, and a comparator circuit. And it's going to be a pretty busy one, so let's see. For these two inverting and non-inverting amps, it is a circuit that amplifies your input signal. So for example, if you had an input that looks like this here, then your output for a inverting amp is going to be, amplified and inverted. So that's the inverting amp. So this is output of inverting amp. And for the output of the non-inverting amp it's non-inverted, so it is in phase with your input. So this is going to be the output of non-inverting amp. Okay, and the voltage follower, it is going to be a circuit that has no amplification at all. So your output is going to be identical as your input. And a comparing circuit it compares whether your input or your reference signal are larger. Okay, so the circuit for a comparator looks like this. It has an op-amp, and your input is being fed into the V positive, your reference signal is going into the V negative input, and of course you have to supply voltages and you are measuring your output. Okay, and the property of this circuit is that if your input is greater than your reference, then your output is going to be Vs positive, which is going to be 15 volt. And the opposite happens when your input is smaller than your reference, and your output is going to be negative 15. So for example, if you had an input that looks like this here, and your reference is a 5 volt DC volt, and if your input is always smaller than the reference, then your output may look like a negative 15 volt signal that is just a DC volt like that. But if you have increased your input slightly so that some portion sticks above your input, your reference, 5 volts again, then your output is going to look like thus. So your output remains minus 15 volt for the portion where your input is lower than your reference, but your output is going to be positive 15 when your input is greater than your reference. And again, your input is smaller than your reference, so your output is going to be negative 15. When your input is above your reference, again, it's positive 15. So you may have something like this. For a more general case, you may have some signal like this. Yeah, this is your Vn. Then if you had your reference, say, and here, it doesn't need to be like 5 volt, but it's just a reference. And then your output may look like this. So here your input is above the reference, so your output is pointing at Vs positive. Okay, and for these time your input is smaller than the reference, so it is going to be Vs negative. This happened to be plus and minus 15 volt because you have applied your supply voltage as plus and minus 15 volt. But if you had supplied this to, I don't know, say 14 volt, then this may be 14 volt and negative 14 volt, okay? And so your input is lower than the reference, so your output is going to be Vs negative, but suddenly at this portion, it is above your reference, so your output is going to be positive 15, okay? So it's like a threshold detector whether your input is greater than your reference or not, and then it shows a very distinct different output, okay? So it compares whether your input is greater than the reference, okay? So let's now talk about the practical stuff. So about the DC power supply, well, all the required materials are op-amp and these clips and resistors. But first, you need to make sure that you correctly select the power supply voltage, okay? So basically, a power supply, well, this is the power supply here, is basically two batteries that are sitting inside, okay? And you would like to select this to be in series by pressing this down and leaving this not pressed. That means you are making these in series like this, okay? So one battery is controlled by the current and voltage on the left hand side. The other battery is controlled by current and voltage on the right hand side. But once you have make this in series, only this guy, the master, is going to control the whole system, okay? And you are using the center point as your ground. So again, there are two batteries here. See, two batteries here, right? This is the head of this battery. This is the butt of that battery. This is the head and butt, okay? And they are connected to each other through this by setting this in series. So these two channels are going to be connected internally. So you are going to use either here or there as the ground, not these guys. These are not the grounds that you don't want to use these, okay? And so with respect to this center point, you are going to have positive Vs and negative Vs, okay? So that's how you create like positive voltage and negative voltage using these two batteries. Got it? So you need to make sure that your negative voltage is connected to this butt of the battery on the left hand side, and the head of this battery on the right hand side is going to be your Vs positive. So once you have make sure that is the DC power is supplied, then you check how to build the circuit using the op-amps. So op-amps, you see here, it has like a dot or a notch like these, okay? And that is kind of the top side. And from the top left, you count like this. So 1, 2, 3, 4, 5, 6, 7, 8. And the 741 op-amp chip that we are using has 8 legs, and 2 and 3 are the inverting and non-inverting inputs. E6 is your output, and you supply voltage via number 4 and number 7. Okay? And you know, the breadboard, the figure from the left and the previous page, your Vs positive, generally you connect it to some of the channels like these, and then you may want to use these rails to have your signal connected. And you know that all these lines are connected electrically internally, right? So you have to put your op-amp between these rows, not on top of somewhere like this. This is not how you want to connect your op amp like this. Because say if you have your legs sticking out like these, like we have 4 legs that are connected, that means this leg and that leg has to be independent to each other. But if you stick them in this same row, then this node and this node are just electrically connected. So these 2 legs are not independent anymore. So this is not the way you want to apply your op amp, but you want to put them in between those rows, okay? So this is another example. If we are going to, well, you are going to build a voltage follower, and it is the simplest example. So your output is being fed into your inverting input, and your Vn is connected to number 3, and you are measuring your Vout. Okay, so what you need to do is number 6 is just being connected to number 2 like this. And so we have done this part. You see, number 6 is your output, right? And you would like to supply your voltages. So your voltage V positive, V negative are being connected to 7 and 4. So you connect number 7. Number 7 is connected to your Vs positive. Number 4 is connected to your Vs negative. Okay, so this is kind of done. This part is done, and this part is done as well. Next part is you need to supply input voltage, right? So your input voltage is being connected to number 3, right? It's connected to number 3. So we have done this part too. And the last part is you would like to measure the output voltage from number 6. So you are connecting this to number 6, and that goes out. So you have done this part as well. So you can check that this circuit is realized in the breadboard. One thing that we need to make sure is op amps are very sensitive. We have quite a few, but we have a lot of students doing the lab, so we need to make sure that these are not blown up. Literally, if you connect those wrong, then poof, it's not gonna explode, but you're gonna smell those bad plastic burning smell, and that's not a good sign. So make sure that there's no DC power connected until you have checked your circuit with RTA NOAA, okay? Make sure that you check the circuit with NOAA or myself before you connect the DC power. Got it? So that is one thing that we need to make sure. And here shows another example of how to connect your circuit, and if you have kind of forgot how to do this, maybe this diagram is going to be helpful throughout your lab. So first step is that you would like to form the circuit. So this is on the inverting amplifier circuit. Your input is being connected to the negative, and then your output you're measuring, and there's a feedback. So we need to do a couple things. First is 2 to 6 through a resistor. So 2 to 6, it's interconnected through a resistor RF. So we did this thing. And from number 2 to your input through a resistor RS. So number 2 through a resistor to your input. So you have a function generator, your output is being connected through a BNC cable. You have to connect your input here, and the another node is being connected to your ground. It is very important that we need to always reference to the same ground, okay? So your input is being connected to the ground. And that ground is the ground we select from our DC power supply. Got that? So this ground is going to be very important for our measurement. It is because we are setting like really the ground. So we have done these two parts, and let's see. We have to still connect number 3 to the ground. So let's have that connected. Number 3 is this line. So number 3 is being connected to the ground like this, okay? And then let's see, this guy is done, and 4 and 7 we need to supply the voltages. So again, from our DC supply, you need to make sure that it's in serial. So these two are connected internally, and that is going to be our ground. And we generally pull out this to a long rail so we can use this ground for all other purposes. Okay, and then one is going to be your VS positive, the other is going to be your VS negative. So VS positive is being connected to number 7, which is done here, and VS negative is being connected to number 4, which is done here. Okay, so we have connected everything for this circuit. So this guy is done. So next we supply the voltage, which is also done. We have connected this 7 and 4. So now what we have to do is we have to measure the input and output using the oscilloscope. So I prefer measuring the input at channel 1. So I would like you to follow this. Why not, right? So channel 1 is being connected to your input, and channel 2 is measuring your output. So oscilloscope is to measure your input and output. So you need to connect a BNC cable. Again, that is going to your reference. Again, the black wire goes to the reference, and the red one is being connected to your input, which is coming out from your function generator, right? So we are measuring the input, and that is being connected to your channel 1. And channel 2 is measuring your output. Again, the black wire has to go to the reference, and the red one is going to number 6, which is your output here. Okay, so this is kind of how you form the circuit for an inverting amplifier experiment.